Transformer. A transformer is a device used in transferring electrical energy from one circuit to another by electromagnetic induction. What do we mean by electromagnetic induction? When you want a coil is just like a copper wire. But it's coated with silver color. When you want it round a metal and you connect both ends to a current, it makes that metal to be temporary magnet. So that is the process or the principles of operation of transformer. Current will be induced on the metal, and the metal by magnet will be able to transfer it to the other circuit. In transformer consists of one, primary coil, where the power is supplied, which is the input. Two, the secondary coil, where the power is obtained or utilized, which is the output side. When the primary coil is connected to a source, an alternating current, the flow in the coil, thereby setting up an alternating current in the magnetic field in the metal by induction. An EMF is set up in the secondary coil or riding depending on winding, depending on whether the transformer is step up or step down. Correct that one. Is winding and not riding. Types of transformer. One, the step up transformer. This is the transformer which takes in a voltage supply at its primary coil and produce an increased voltage on the secondary coil. Also, the number of turns of coil in the secondary coil is greater than the numbers of turns of coil in the primary coil. Look at the diagram. We have 100 volts. That V represents 1,100 volts. And we have 10 ampere. And the power rating that enter is 1,000 watts. Look at the secondary coil. In the primary coil, look at the green inside that metal. There is 5 turns. For the secondary coil in red color, we have 20 turns. We have 400 volts. And we have 2.5 ampere. The same 1,000 watts. So, with that, you will see that as the voltage is increasing, the current is reducing, and the number of turns of coil on the secondary coil is increasing. 2, we have the step-down transformer. This is the transformer which testing voltage supply at its primary coil, which reduces the voltage. Correct that one also. Not testing. Reducing the voltage supply at its primary coil and produce a reduced voltage. It takes in voltage supply at its primary coil and produce a reduced voltage on the secondary coil. Also, the number of turns of coil in the secondary coil is less than the number of turns of coil on the primary coil. Look at the diagram also. We have the 1000 volts. We have in blue color, we have the 2 ampere, that is the amount of current that flows in, and 2000 watts for the power. Look at the numbers of turns of coil, which is 50 turns. And look at the numbers of turns on the secondary coil, which is 10 turns. Then the voltage increased from 1000 to 200. And we have increase in current, which is 10 ampere from 2 ampere. The power rating remain the same. What are the uses of transformer? Transformer is used to step up the voltage of alternating current supply. It's also used to step down the voltage of an alternating current supply. It is used to generate and transmit electricity to all electronics appliances. In Nigeria, the voltage of electricity supply by NEPA to our houses is 220 volts. In some countries is 150, some are using 110. So, and any appliances that will be taken to those countries must be according to their voltage supply. It must be according to their voltage supply. In USA, it's 10 volts. And look at our own. Our own is 220 to 250 volts. Take note of that. So the calculation involving transformer. The induced EMF is electromotive force. It's also the same as voltage or potential difference. In the primary coil, depends on the voltage at the secondary coil and also the number of turns of winding in both coil. Therefore, voltage in the primary coil over voltage in the secondary coil equals to number of turns in the primary coil over numbers of turns in the secondary coil. Then you can look at the example. When we want to apply the formula, so EP represents the voltage, the primary voltage, while ES represents the secondary voltage, while the NP represents the number of turns of coil at the primary, and the NS represents the number of turns of coil at the secondary coil. Example 1. The primary voltage of a transformer is 10 volts and the primary winding is 20 turns. If the secondary winding is 100 turns, find the secondary voltage. From there you can say, you can give the data, state all the data that appear in the question, and from there you can state the formula as EP over ES equals to NP over NS. Therefore, since we are looking for ES, you can therefore make the ES, that is the secondary voltage, the subject of formula, which the primary voltage multiplied by numbers of turns of coil over the numbers of turns of coil on the primary coil. So 10 multiplied by 100 over 20. So 20 in 20 give you 1, 20 in 100 give you 5. 5 times 10 now give you 50, and that is where we have our secondary voltage as 50 volts. So this transformer, if you look at the primary voltage from the question, the primary voltage is 10 volts, and from our answer here, the secondary voltage is 50 volts. So they may ask you, which type of transformer is this? This transformer is step-up transformer. It has increased the 10 volts that enter into it to 50 volts. So now we have other aspects. Transformer efficiency. How do you know that this transformer is efficient? Since transformer is a device that operates with principle of conservation of energy, so that the power or the energy per second supplied to the primary coil is equal to the power developed in the secondary coil. The efficiency of transformer must be 100%. Where is less than 100%, that transformer is not efficient. So efficiency of transformer equals to power developed in the secondary coil over power supplied to the primary coil. So output over input, which is also equals to output over input multiplied by 100. So they will give you the output voltage, and they will give you the input voltage. Whatever answer you get here, you multiply it by 100. So if it's 100%, the transformer is efficient. And note that a very high voltage of electricity from the generating station is stepped down at substation in the town, city, or villages before supply electricity to our houses. So all these are very important, and you must take note of them. God bless you.